Greetings. Welcome to W4U3 problem based approach to instruction. In the earlier unit W4U2, we understood implementation issues and guidelines for project based approach to instruction. The outcomes for this unit W4U3 are understand problem based approach to instruction. The term problem based approach is being used in several broad senses these days. Sometimes the term is used interchangeably with terms like inquiry based approach, active learning approach, experiential approach, and so on. All these terms have certain common features, yet they are all distinct. However, problem based approach often is used interchangeably with these terms. Actually, in the literature, problem based learning is the more common term. However, we use problem based instruction PBI in the sense that it is the approach to instruction that results in PBL. As PBI is the approach that results in PBL, often in our presentation we will use these terms interchangeably. Though strictly speaking we should be saying PBI, we will also use PBL to mean essentially the same thing. PBI is the approach that facilitates or results in PBL. It is generally perceived that PBI values effectiveness over efficiency. That we will see has several implications for adopting PBI in engineering programs. Historically, PBI was developed in the context of medical education, 1969 McMaster University. One good definition of PBI is a progressive, active learning and learner-centered approach where unstructured problems are used as the starting point and anchor for the learning process. Here, the key ideas are active learning, learner-centered, unstructured problems. So, these are the key aspects of PBI. This definition is from TAN, Problem Based Learning Innovation, using problems to power learning in the 21st century. It's quite popular in medical education and allied areas, but is being used more and more in several other domains also. Not only traditional medical education, nursing education, physiotherapy, etc., but in some other programs like arts programs, engineering programs also, it is being adopted. What are the key principles for PBI? First principle is formulate and provide authentic problems to learners. What we mean in this context is that problems must be compatible with the intended outcomes and encourage cross-discipline thinking. The second feature is student-centered learning and self-directed learning. This approach is basically student-centered and it is self-directed learning that is of importance. Collaborative teamwork and interdisciplinary integration. Teacher plays the role of a coach, tutor, supporting the development of learners' metacognitive skills and her problem-solving abilities. Though she plays the role of a coach or tutor, this role is not like a conventional role that you find in more traditional settings. The teacher never provides the content directly. In that sense, even as a coach, she is not directly helping with the solution. She is only helping with metacognitive skills and the students' problem solving abilities. The teacher is never a provider of the content directly. In that sense, Though we use the term coach slash tutor, we really do not mean them in the traditional roles. The next principle is formative feedback and assessments that validate the outcomes. The last and important step, thorough debriefing to consolidate the key concepts gained from the learning experience. Let us discuss authentic problems in greater detail. The problems should reflect the cognitive demands that are consistent with the environment for which the learners are being prepared. The problems should be ill structured. Learners must be able to deal with this kind of problems in real life. So the problems should be ill structured, similar to the kind of problems that they will actually encounter in their profession. The problems should be complex enough to challenge the learners individually and as a team. Problems must be contemporary and be able to excite the students. The domains as well as the problems in the domain are selected by the instructor in accordance with the intended outcomes and are then assigned to students. The problems are open-ended with no unique correct answer. This scenario is similar to what the students would encounter in the real life in their workplaces. There is no unique or correct answer. So the students must become comfortable with this idea of solving a problem yet not having a unique correct answer. PBI is designed to support higher order thinking skills and is not appropriate for teaching basic skills. The learners must be having some knowledge to start the process of engaging with the problem. Instructor may have to provide some initial instruction and learning materials as well as. The learning materials are obviously curated learning materials. This process is called scaffolding. We will discuss scaffolding in a later unit. Example problem scenario. It's presented more like a case study. A local non-profit organization that supports underprivileged youth has an outdated, poorly designed website. It's not mobile friendly, has accessibility issues, and fails to engage visitors. The organization has contacted your department for help. The department has assigned the problem to your team. So now you can see this is a realistic setting in the sense that the problem is fuzzy, there is an open-endedness to the problem and it is complex. So you have to help them to re-specify the site to better serve their users, donors and community partners. This is just an example of the kind of problem scenarios that happen in PBI. Student-centered learning and self-directed learning. Students take responsibility for their own learning by identifying what they need to learn. In order to solve the problem, what are the domain areas that they need to learn and what are the additional knowledge and skills that they need to learn in order to solve the problem. Students take responsibility for all these issues. So students identify their own learning needs and conduct independent research to address gaps in their understanding, what they know and what they identified as required knowledge to solve the problems. Whatever gaps are there, how do they fill it up? So students have to take responsibility for all these things. Obviously, if the students are not able to proceed further because of issues with their understanding of the process, teachers may help. Scaffolding, what we discussed. While teachers may help, coaching, tutoring, all these things, They are never direct providers of content. So students have to work through all these things and teachers may help them in the process. Collaborative teamwork and interdisciplinary integration. Students typically work in teams, simulating real engineering practice and promoting communication and teamwork. They decide on their roles in the team, who is to be a research coordinator, who is to be a designer, etc. And such roles can change dynamically. This is also required because the students must acquire and demonstrate their skills in all these roles. In real life, they must become competent in all these roles. Of course, this change of the roles is dynamic and the team itself decides on what roles the members have to play. Students draw on knowledge from multiple courses or fields to solve the problem. Instructor roles, we kept on emphasizing the importance of instructors' roles in the success of PBI. It's really critical. Role of instructor is as a facilitator of learning, tutor, and not as a provider of content. Tutor may not even be an expert in the relevant domains. It is possible that she is an expert in the relevant domain, but need not be. Tutor may just help the learners contact the required experts and get the necessary information, and tutor may help in this process. So, the role is not even that of a regular conventional coach. Must probe repeatedly to ensure learners do not stop their work too early. One of the challenges in PBA is that it's quite possible for the learners to become disenchanted with the process of learning or become depressed, disappointed with the lack of their progress, and they may lose interest and they may stop work prematurely. The instructor must interact with the learners and probe repeatedly to ensure that learners do not stop their work prematurely. If the instructor finds that some kind of problem is cropping up with the progress of the students, the teacher must take appropriate action. We will discuss some of the approaches again. The teacher focuses on group processes to ensure the participation by all learners in the group. This is also required. All learners must be able to articulate their understanding of the problem solving process, the information gathered from research, and its relevance to this task of problem solving and the proposed solution. While the students may have different roles, all of them must be familiar with all these aspects and they must be able to articulate all these things. So, instructor facilitates this process. That is, all learners must articulate their understanding of the problem solving process, and so on. So, while the process is being implemented, the roles may differ and they may dynamically change, but everyone becomes comfortable with the process and what they need to gain from the process. So, instructor must facilitate this process. Now, in this entire process, as we mentioned, it is possible that the students are stuck. They are not able to progress further, and teacher finds that some kind of mentoring, coaching, scaffolding is still not able to help the students. Then she must take a call and decide whether the problem posed initially has to remain unchanged or whether it has to be changed. So instructor must be able to sense when the problem is boring or frustrating the learners and must modulate the problem accordingly. It's not that there is a rigid requirement that the teams have to stay with the problem as given originally. So very important to realize that the problem posed initially may or may not remain unchanged during the learning process. It is the instructor's responsibility to see if there is a need to modulate the problem and modulate it accordingly. Formative feedback and assessment. Regular formative and constructive feedback is provided and students reflect on what they have learned and how they are working towards a valid solution to the problem. This is an extremely important one, and the feedback is formative, so it does not lead to any grade related issues, and it is constructive, so it helps the learners realize what are the successes that they are having and what are the mistakes that they are committing, what are the errors in their reasoning, what are the errors in following the process, all these things. So the constructive feedback helps the learners. On the other hand, a purely destructive criticism is of no use in improving the abilities of the students. So regular, formative and constructive feedback needs to be provided. Assessment, both formative and summative, is a critical activity in any education system that way, but is particularly important and complex in the case of PBI. Assessment must be aligned to the intended learning outcomes. So, what are the things to be assessed? Obviously, first, knowledge and skill in the relevant domain, but more important is the process and the reflection. What is the process followed by the students and how they are able to reflect on the process, their experience with the process, their learnings from the process, and their reactions on the feedback. So they need to reflect on all these things, the process and the reflection. That needs to be assessed by the teacher. It's not an easy job, but that is important. Then collaboration, how the students are collaborating and how they are able to play the different roles and remain comfortable with those roles. Communication, that is extremely important for the teamwork to proceed, and that is an important feature of PBI. Metacognitive thinking, because it is not passive learning from the teacher, but it is active learning by the students who take the responsibility for their own learning. It is important that their metacognitive skills are improved. So, the metacognitive thinking has to be assessed. Solution quality. Here, when we mean quality, it does not mean that it is the right answer or anything like that, because this process does not demand any unique right answer. But just what is the quality of the reasoning employed, what is the quality of the solution proposed, what is its internal consistency. So essentially these are the things which are assessed. Summative assessment of the final solution presented by the student teams in whatever format specified. They may specify it as a report, or they may specify it as a presentation, or they may specify it as a group inquiry report. Whatever be the specification, the final solution must be presented in that format, and if it is from a domain with which the instructor herself is not familiar, it may require experts and appropriate rubrics. Experts probably perhaps from that domain who are external to the institute. Students may need to be trained in activities like maintaining reflective journals. This is an extremely important activity of the process. They must reflect on their participation in the process and its outcomes. Experience across the institutes vary, but they need to experiment with different assessment techniques and see that they are able to evolve assessment methods best suited for them. There is no unique way. Then the last important feature is debriefing. This is not to be skipped at any cost. This is an extremely important and essential feature of PBI. This debriefing is essential for the benefits of PBI to be realized. It plays a crucial role in consolidating the learning, reflecting on the problem solving process, and promoting metacognition, thinking about one's own thinking. It helps learners recognize, verbalize, and integrate the new knowledge with the previous knowledge. Notice that in an earlier unit on Merrill's principles also, we mentioned the importance of this integration of the new knowledge with the previous knowledge, and that is a feature of reflection. And the students must engage in such a reflection and maintain that as a journal. So, this debriefing occurs after students have worked through a problem and ideally involves both facilitator led reflection and student self assessment. Both are involved in this. Benefits of debriefing: consolidation of knowledge, helps students make connections between new knowledge and prior learning, facilitates transfer of learning to future problems. This again is an important aspect of deep learning. We discussed this in the Gagner's principles also. Reflection on the process encourages discussion of group dynamics, decision making, and the strategies used. Students assess what went well and what could be improved. This is part of reflection. Clarification and correction. Facilitators can address misconceptions or gaps in understanding. Provides an opportunity to confirm correct reasoning. So there are many benefits of debriefing. And encouragement of metacognition. As we mentioned, one of the key aspects of PBI is that students take care of their own learning, and this requires good metacognitive abilities. So, the debriefing step encourages the metacognition. Students think about how they approach the problem, they discuss it. Debriefing helps in developing self-directed learning skills. Then another benefit is feedback loop. Both peer and facilitated feedback help improve future performance. The feedback can come from the teammates and it can also come from the teacher. And this constructive feedback helps the students in performing better in the future cases. This feedback loop promotes continual improvement and lifelong learning habits, an extremely important outcome that is expected from the NBA process also. So, in the next unit, we will understand the implementation issues and guidelines in the context of PBI in engineering programs and compare PBI and PGBI. So, in W4U3, we conclude the discussion of PBI, the implementation challenges, its guidelines, and compare PBI and PJBI. Thank you. We'll meet again with the next unit. Thank you.